So the other day I was online looking at a couple different types of motors, and there's one that kind of caught my attention because it didn't have any permanent magnets in it. It simply had a coil, and the rotor, or the part that spins, was made of only iron, or in my case I have steel, which is mostly iron. And the theory of operation is that instead of creating a magnetic field that pulls another permanent magnet into alignment with attraction, instead that what this does is aims to create a full path for the magnetic flux, or the lines of magnetic field, to connect. See, the current flows through a conductor, but electromagnetic lines of flux, or the electromagnetic field, will flow through steel, and it aims to have the shortest possible path. And the path is fixed all the way around this sort of C shape, except for where the bolt is, and there's a bit of an air gap that the magnetic lines of flux have to jump through. Now, whenever the bolt is oriented like this, it is the shortest possible loop, but if the bolt is rotated, the air gap increases, and in other words, the imaginary, or not imaginary, but invisible lines of flux have to jump a greater distance to get through the bolt to the other side and meet up to where it began. And of course, this coil here is what's generating that magnetic field, or the flux that's going through. So the system wants to reach a stable state, or a lowest energy state, and that is whenever the path is shortest, and it will pull the bolt into alignment to create that shortest path. So if right now I just have a DC power supply from a computer, so it's like 20 volts ish, and it can put out a couple amps. It'll probably spark a little bit, but just watch this bolt. At first we'll probably just see it twitch a little. See that twitch? That's really cool because there are no magnets in this circuit. It's just steel and copper windings. And if we rotate to the other side, it will now spin opposite direction again to try to get itself in a shortest loop. So if you wanted to make a motor out of this, you would have to have another loop that is 90 degrees, or maybe have 3 loops that are offset, one here, one 120 degrees apart from each other, and then you could pulse the coils on and off in the right order and get it to advance from one location to the next. So this is probably a pretty terrible setup. Like I have actually a lot of air gap. Usually you would want the air gap to be as small as possible because steel conducts magnetic lines of flux way better than air does. That's why we wrap wire around iron core when we make transformers, because it's so much more efficient. You could make an air core transformer, but it just wouldn't work. So if I wanted to make this a little bit better, instead of this bolt, I could have a piece of metal that was very close to the almost touching but not quite touching the metal, and then we should see a greater magnetic, or a greater attraction. The other thing I could do is, rather than just a bolt, which will probably not twitch at all whenever it's we don't get much attraction there because the air gap is way too much. Perhaps I could put a disc, or a different shaped disc, or a disc with cuts in it to vary the I can perhaps it would have slots cut into it that would make it so that a certain orientation has the shortest path, or whatever. There's more you could do, but the principle is working, in that we're able to create a force acting on the rotor with using only a coil, and no permanent magnets, and so that's pretty cool. I'd say the implications of this, or the reason why motors like this are desirable, is that permanent magnets, neodymium magnets, are more expensive than steel. And copper, of course, is expensive, but you have to have copper in just about, I think, any type of motor anyway. So you can cut your costs by having a steel rotor and a steel stator. Now, the drawback is that the control electronics of this type of motor are more complicated. It would actually be very similar to a brushless DC motor, in that you can't run it directly off of a battery. I can get it to twitch directly off of a battery or a constant DC source, but I would need to have multiple poles or multiple paths for the flux in order to attract it to, in increments. So that's as I'm just sort of experimenting with. By the way, the type of motor is a let's see, reluctance. It's a reluctance something. It's the same kind of as a stepper motor, except a stepper motor would have, a lot, maybe 100 poles that go around, just in the way that the rotor is designed and the stator is designed. It has a whole bunch of different increments, and by pulsing the two coils in a certain sequence, you can get the rotor to advance very precisely. So that's the reluctance motor, or at least it's not really a motor, it's just a twitching bolt, but it's some of the concept. So I hope you enjoyed the video. Thanks for watching.